Okay, let's first finish up the math models, and then we'll talk about the next design pattern, which is also very interesting. Okay, I would like to just point to you one more thing about the math models. Why are we using it? So the main thing is really about single choice principle. Okay, if you have doubts about it, review the lecture slides from last time. Okay, but single choice principle is why we need for math model, especially in the context of contracts. We talk about every time for your particular implementation, which should be hidden, exported to none. We introduce something that is public, but some of you have concern from last time about deep twin kind of issue. I'll talk about it just after this slide. Okay. And then we have model here, which is abstract, let's say sequence. And we're going to see more examples today about functions, relations, or even graph. You can explore the graph yourself, okay, just for your interests. And then notice that over here, we just have a single function here, and it's called abstraction function. We're basically promoting your thinking above the level of the code, thinking about abstract mathematical objects, like a sequence over here. And then just do a loop and do whatever implementation is necessary. The only place that you have to mention about implementation details would be in the post condition over here for the model. That's the only place. Okay? Everywhere else, whenever you want to write contracts, for example, let's say for the push, and for the push in different strategies, you will basically use the same contracts. Okay, just to show you. Let's say for push, you will simply the model will be the same as appended to the new model, right? And also this identical contract over here, and also identical contract over here. So the contract remain very stable. Okay, that's the main point about using math model. Okay, let me go back to I believe Tammy and Wuma. You got a concern over here. Okay, so now let's consider this scenario over here. Basically, the concern is we have model over here, and model is basically exported to any, right? Anyone can use it. Okay. Let's say we still keep this one model just being a sequence for illustration. Let's say we have potentially some very evil clients, but let's try to see what an evil client can do, and let's see how we can prevent it. Okay? Let's say we have a client side of the code. We declare a stack of account. Remember, stack is generic, so we simply instantiate G by account. So now let's say we simply s.push, s.push, s.push. We basically push 3 accounts into the stack, and then tell me something. Is this line compilable? Would it compile? Can I say s.model? Or let me give you some comparison. If you compare this line over here as opposed to this line, okay? Let me write something alternative. If I say maybe, let's say list is assigned to s.imp. Number 1 and number 2. Should number 2 compile? According to the setup, I heard no. Just tell me the reason. Exported to none. Exactly true. Okay, just make sure. So this would not even compile, and because it's exported to none. However, this will compile because exported to any. Okay, good so far. And think a little bit more about it. You can think of what's happening under the hood is like this. Let's say we got Alan, we got Mark, we got Tom. You can think about we have basically 3 accounts object. Let me move this guy. Oh, sorry, not this guy. I want to move this guy a little bit. Again, it wouldn't let me. Okay, that's never mind. Let's say we have basically 3 accounts. Okay, ACC for account, ACC, and also ACC. Let's say the account for Alan, the one for Mark, and the one for Tom. Basically, what's happening here is like this. When you talk about implementation is basically a linked list like this. That's the implementation. Let's say only 3 elements so far. The first one pointing to Alan, and then to Mark, and then to Tom, let's say. Okay? Yeah. So far so good? Okay, just a linked list. And the model itself is actually, without doing anything, if you simply follow this particular code, this is how it looks like. So if you think about the model over here, if I call the model, it's simply going to construct a mathematical sequence just like an array. okay? And then it's really pointing to the same objects. Okay, that's kind of the setup at the runtime. If you have a very kind clients, they wouldn't really try to manipulate anything about the model in a way that you wouldn't expect. However, that's the setup at the runtime. So now, given that this line is possible for client to write, can you imagine what's going to happen next step for E4 clients? Give me some example. Anybody? I can give you one example. Okay. Unless anyone want to speak up right now. Well, I can give you one. Yes, go ahead.
If it changes of value sequence and then because it's pointing to the same object from before,
you mean maybe redirecting the pointer somehow, right? That's one thing, I would say there's something that's even more evil. Remember when we talk about complete postcondition, what you really want to prevent is any changes beyond the first level. Okay, what about this? If the client was able to get a model over here in the sequence, right? I can say, for example, s the model, let's say the top, okay? Dot withdraw. For example, 1,000. They can easily get access to the top of the stack, even though they're not supposed to, right? That's kind of the danger we have. Because the model itself being public, and also each element in the model sequence is really referring to the same objects. Basically, it's just about aliasing. For aliasing, we can change the same objects using different paths. And we're basically following the path from the model part, right? Going for the model and then going for this particular element, we are just changing it. Okay, that's pretty bad. Now, how can we solve this? Make a deep twin at which level? Should we ask the client to make deep twin? Well, they are not so controlled by us, right? They can do whatever they like. So for us, as a supplier, we have to prevent it. Okay? Any suggestion? Should we change somewhere? Where should I change? Where? Sorry. In the model, yes. I would say a very quick solution would be, I can simply say over here, result is assigned to result dot deep twin. So that will basically make sure every time I return something, it's going to make sure. So now, alternatively, let's say this is the version I'm going to draw in pink. Okay, this is now the new version. What's going to happen is when they actually request for model, it's actually going to just return exactly again a sequence of 3 accounts. But now, rather than things like this, which will be aliasing, it's just going to create 3 account objects separately. And those, if they want to play with it, feel free. It's not going to affect the original ones. Is this efficient? Apparently not. You're going to waste a lot of spaces. If you got 1,000 account, you're going to make a deep twin. However, remember, that's going to be efficient for the EVO client, not for us. For the EVO client, they are not for any clients, they are not supposed to manipulate on the model. It's only meant for contracts on the supplier side. And we know that when we finalize the projects, we're going to turn the contracts off anyway. So it's still going to work. Okay? So guys, is it clear? Okay, so the take-home message is, if you wish, you can put deep twin over here to really prevent the issues from happening. Yes? Mm-hmm.
So will we have to put like hits to make sure that?
Yeah. So remember the issue is whenever you turn off the contract, that means you're closing your system. So that means you turn off the precondition, turn off the postcondition, turn off the invariants. Before you do that, you make sure you exhaustively test your system, so everything's going to work. Mm-hmm. Yeah. So that's not an issue here. Jordan, you okay? Okay. I thought you raised your hand. Okay. All right. Guys, it's okay? Okay, that's only just extra because some of you actually raised that question. Pretty good question. Okay, so now I would like to talk about 2 more things about math models. Number 1, I want to just talk about maybe 2 or 3 operators just to do a quick review and show you how things work. And then number 2, I want to go back to the birthday book and do a little bit contract with you. Make sure you're comfortable. Okay, 2 things, and then we'll go to the design pattern. First thing first. I want to explain how this particular operator called overridden. Okay, overridden. That's something I want to do first. And then what I will do is, let me say this. The best way for me to do is to make a copy of this and then start a new page, and then we'll do overridden. Okay, let's say this. Oh, sorry. Copy the wrong thing. That's what I meant to do. Okay, just that. So now I want you to focus on just this particular relation. Okay? So one way to look at a relation is think about it just being a list of pairs, set of pairs. The first element will be the domain, and the second element will be the range. Okay? Let's see how we can visualize this very quickly. Okay? Well, that's pretty much what you did back in 1090 or 1019, I don't know. So this will be the domain, and this will be the range. Okay? So we got A1, so that means A maps to 1. We got B2, B maps to 2, C3, okay, we'll do that quickly. And then A maps to 4. And then B maps to 5, okay, and then C maps to 6. And D maps to 1. Yeah, okay, still readable. And E maps to 2. And then E maps to 2 over here, and F maps to 3. I'm sure you can draw much better than I do. Okay? Basically, that's kind of the relation, right? Is it still readable? Somehow, right? Okay, sorry about that. So B1? B1, yeah, exactly. Yeah. Okay. Oh, yeah, exactly. You're right. You know what? The best way for me to fix this, sorry, that's too big. The best way to fix this is, okay, get rid of this part here, and then to 1. Okay. Anyway, how do we visualize overriding? Okay. So now let's say this is R. If I say R dot override, and usually when you do the override, you have to give a number of things. Okay. Let's say if I want to do override by, let's say A1, and then, let me just do exactly what's on the notes, so that'll be easier for you to see. Okay, sorry about that. So now the one we want to do is, we want to do overriding by A3 and C4. Okay, let's see what's going to happen. A3 and then C4. Okay, that's what we want to do. Overriding. Overriding simply means somehow after the overriding, we want to make sure for the domain value A, it only maps to 3. And for domain value C, it only maps to 4. Okay, that's basically what's going to happen. Okay, so now you can think about, but everything else remain unchanged. So what we'll do is, you can think about what's going to happen will be in 2 steps. First of all, for this particular domain value A, we're going to wipe out everything it is mapped to at the moment. So we're going to get rid of used to map to 1 and 4. So I'm going to wipe out this arrow here, and also wipe out this particular arrow here, right? So I'm simply getting rid of for A. And then instead, I'm going to map to 3. Okay, that's for the A part. All right? And then what about for the C? For the C over here, and then I'm going to wipe out exactly over here. C used to map to 3 only, 3 and 6. Okay? So now I'm going to, you know what? Actually, before the class, I thought this way might be easier to visualize. You know what? Maybe let's focus on the text over there. It's easier. Okay? I did the other way last year. I thought maybe to try this year. It turned out to be quite messy. Okay? Can we try it the other way? Okay. It turned out to be much easier. Okay? Forget about what I just said in the past 5 minutes. Sorry for wasting your time. Okay? Now, the easiest way to visualize this is this. Okay? Much easier. You'll realize why. To override into A3 and C4. For A, get rid of this. Okay? Get rid of that. And then simply put in A3. And then for C4 over here, get rid of this and get rid of that. And then C4. And that's it. That's the override. Basically, what you're doing is you're going to remove all the existing mappings for A first, and then add in A3. And then remove all the existing mapping for C, and then add in C4. That's basically what you're doing. Okay, that's overriding. So now let's do a very simple example over here as an exercise. Okay. Rather than having this, can you tell me what's going to be the result when I say R dot override? Okay, so now I want to do, let's say, G4. And then I want to do B6. Okay, like that. This is the new exercise for you. Basically, think about the two steps. First of all, you're going to remove all the existing pairs for G, and then adding G4. And then move all the existing pairs for B, and then adding B6. Okay? Make sense? Okay. So now let's do that together. How do I remove all the existing pair for G? So now so do I have G? Nothing to remove. And then just adding G4. G4 will be the new pair. Do I have B? Yes. So B, get rid of it. B, get rid of it. And then B6. That's the new relation. Okay? More mathematically speaking, okay, what you will see on the slides is simply tell you that the first stage is something called domain subtraction. Okay? You're going to subtract from the relation everything whose domain is A, for example. Okay? That's basically what's happened. Let me just do one more for domain subtraction. You will need it. Okay? Let's talk about domain subtraction. So now let's say R dot domain subtract. If I say, for example, domain subtract A. Okay? So now, currently, let me just make it easier for you to respond to me. 1, 2, 3, 4, 5, 6, 7, 8, and 9. When I say domain subtraction, I simply means remove all the pairs whose first element is A. So now, after doing this, how many pairs would I get left? I heard 7. Agree? Okay. Simply because you can see only 1 and 4 are related to it. Because the first element for 1 and 4 is simply just A. So remove them. Okay? That's domain subtraction. You got something very similar to it, which I'm going to illustrate on the same spot. Okay, the same relation over here. I'm going to say something called range subtraction. Range subtraction. What that means is I'm going to give, for example, let's say 2. You can see, in one case I talk about numbers, in the other case I talk about A. So for range subtraction, remove all the pairs whose second element is 2. Okay? So now, again, just one more exercise over here. 1, 2, 3, 4, 5, 6, 7, 8, 9. So which one should I remove? Seems like 8, right? 2 and 8. Agree? Okay. Good. You got it. Sure. Let me just remove them. 2 and 8. Okay. Remove them. That's range subtraction. Yes, question.
So why domain subtract is a set within the range subtraction?
Oh, sure. Simply because I forgot. Yes, absolutely. Yes. So typically, when you say domain subtraction or range subtraction or that kind of thing, you can do it. You can even either do a set or you can do a single element. You will see that when you see the API for those classes. But conceptually, that's how that works. Okay. So guys, when you review the slide, let me mention one more thing before I answer your question. You will see something called domain restriction and also range restriction. I might just do them anyway, since we talked about it already. Compare this domain subtraction with, let's say, over here, let me use blue. If I say r.domain restriction, and then I'll just put a set element, just say A. So now what does that mean? All the pairs, yes, all the pairs where the first element is simply A. In that case, what would I get back? I'll simply get back another relation, but with how many elements? How many pairs? 2. Yeah, exactly true. Okay? So that means I'm simply just going to get this guy here and this guy here. So that one will just give me back A1 and A4. Okay, I'll say these are the typical ones. So get familiar with at least override, domain and range subtraction versus restriction. Okay, that's something you will need when you do the lab and also later evaluation. Any questions about this? Yes? You will actually see in the, to be more precise, when you see the math models, okay? Remember we said basically you got command, you got queries, right? What you will see in the math model is, when you say if I have a relation R, if I say R dot override, and with some argument over here. So this is a command, which means it is going to modify R. So that is not suitable for writing contracts, because in contract everything should be immutable, right? Return something. On the other hand, which we'll see, if you want to write using override in the contracts, they have an immutable query version. When you say R dot overridden by, in that case you pass something over here. So this one here is an immutable query, which means it is going to return just another relation, which is similar to that, except that it has been overridden. Okay. Okay, that's something we'll see maybe in the birthday book example, some parts. All right. Any questions? You okay? Yes. Depends on which you are calling. Very good question. I will draw your attention back to the original example. Okay. The question was, should domain restriction, okay, let me just make it precise for you. When you look at the example on the slides, you will see that I was trying to call 2 very similar features over here. One is called domain subtracted. The other one is called domain subtract. You can easily tell just from the line, this guy over here is basically a immutable query. And this guy over here is a command. Our convention is if you see the feature name being like a verb, in that case it's a command, otherwise it's a query. Okay? So which one should you use? It depends on the context. If you want to implement your abstraction function, you should use the command version to build up your relation. If you want to use it for the contracts, you may want to use the upper one, the immutable query version. Okay, yeah, yes? How the function and relation is related to sequence. You mean mathematically or in math models? No, actually, okay, think about this. In the case of the math model, you can think about the math model, you simply got separate classes. You don't usually use them together, okay? You got sequence, think about that as an independent class, okay? And also you got set, also you got relation, also you got function. So these are the main primary classes in math models. So one design choice could be maybe a function simply inherits from relation. To say function is more like a specialized kind of relation, where each element in the domain can map to at most one element in the range, right? Something like that. So we don't really use the relation and function to explain what a sequence is programmatically. That might just confuse you. So yeah, I would say, but for the purpose of this course, I think these are the main classes you want to get familiar with. But you don't need to memorize a signature. We'll give you. Okay. All right. Any question about the example here? We okay, right? Okay, because tracing that code can be a little bit tedious. I don't want to waste your time. Okay. Okay, but anyway, I would say when you study that, you can have a look quickly here. Okay, this is a very typical setup. So you can say if I declare some relation over here, what I need to do is like this. I declare relation, and this is the type for the domain, and this is type for the range. I'm mapping from string into integer. Okay, and then the easiest way to build up some relation is like just give it an array of tuples, right? It's like a set of pairs, and then you got string and then integer, etc. Okay, and then after that you can either call the command or you can call the query to get whatever you like. Okay. Yeah. Otherwise, you can also refer to the mathematical definition I put over here. You can go over that too. Okay. So for that one, I rely on you to study that. Okay. If you've got questions, let me know. Okay. Is it okay to let you study for that? Okay. Good. Any other questions before I move on to birthday book? So now we are ready to do the birthday book contracts using math models. No questions? All right. Let's talk about birthday book. For those of you who maybe just forgot, very quickly. The birthday book basically is going to be a set of entries. It's going to be name to birthday. A very simple example is something like this. So the domain will be simply just the name of the person. And then the range will just be the birthday, right? We somehow debated a little bit last time before the end of the class. Should the birthday book, abstractly, should it be a function or should it be a relation, right? We kind of decided that it should not be a relation. Why? That's something you should know how to justify. Yes? Yeah, exactly right. Because a relation means, for example, I got another one. Let's say Jim. Jim can easily have August 11 and also October 15 being his birthday. Is this a valid relation? Absolutely, because each element, there's no constraint whatsoever on the mappings. So that's a valid relation. Okay, so this one is a valid relation, but not valid book. So relation is not suitable for birthday book. Okay, that's something we talked about last time. Okay, so now let's now see a little bit of bound diagram and see the design, and then we'll see a little bit of implementation as well to get the idea. Okay. Now let's talk about it. Somehow I block everything that I think you should really try to exercise. Okay, and then we can discuss together, go over quickly. Okay, but let's see the overall picture over here. Okay, so what we have is, okay, let's focus on different parts. Let's see the birthday book first. You have the birthday book class over here, and then we are abstractly speaking, every user is going to view the birthday book as a function, where the domain is a name and the birthday, the range is the birthday. Given the name, if it exists, it's going to uniquely identify some birthday. Okay, that makes sense. Good. And then you can also do some invariants over here. For example, you want to say the count, which is like the size of the birthday book, should be the same as the size of the relation. Okay, good. That one's easy. All right. We haven't talked about implementation just yet. We will in the next slide, but not yet. Exercise number 1 for you. Given this, what kind of client-supply relation do we have? I'm helping you draw a bound diagram. Hopefully that'll prepare you for the exam, I hope. Given this particular declaration of model of type function, name, and birthday, right? What kind of client-supply relations do we have? Or at least, who is the client? Yeah, because that's where you declare the attribute, right? So where you declare the attribute should be the clients, right? The client should be the birthday book. What about the supplier? How many suppliers do we have over here? Well, 4. Which 4? But we don't have integer here, do we? We got function, we got name, also we got birthday. We don't have integer over here. So integer doesn't count, right? So now, if you really want to draw the complete picture, so these are all possible candidates. Function is something we are using, so that's a supplier. Name and also birthday. So these are all the potential suppliers we can draw. However, when you draw the bond diagram, you don't necessarily have to draw everything that's declared. Just choose. Okay? Let's say we decide we want to focus on the function part to say abstractly speaking is a function. Okay, now, so I will simply draw a client supplier label over here, okay? And then I'll declare model over here, and it's pointing to, oh, beg your pardon, what I meant to say, let's focus on birthday. Okay, sorry about that. And then I'm going to say it's going to point to the birthday here. Question for you, what should this part be? Okay, I mean, write it out. That's pretty good. Okay, can you tell me again? I'll write it out. So model is of type something, right? Okay, so we still do function here, right? Just to be precise. Okay, and then? Comma, dot, dot. That's exactly right. Guys, that's the what you're supposed to write as a label. Okay, let me explain again, okay, what that really means. Basically, what you're saying is this particular label over here, when you say model, and then it's of type function and name, dot, dot. The reason that we don't really mention that is exactly the dot, dot mentioned is talking about the thing that's being pointed to, which is birthday. So this is the birthday. Okay, that's basically, so you don't have to say birthday because it's already being pointed to. Everything else that's not being pointed to, you have to mention them. Okay? If you only say model, for example, you simply say dot, dot. What you're saying is, in your client class, you only declare model to be of type birthday. That's not right. Okay? Okay, that's simply not right. Just want to mention to you. Yes, question.
Saying model dot dot, same as just saying model on top of the arrow and having it point to birthday, like for bond diagrams.
What's it again? What do you mean?
Like you know how at the bottom you have model colon dot dot. Is that the same as just having the same model on top of the arrow that points to birthday?
No. Yeah, exactly. Yeah. So here I'm just saying this one here, according to our declaration over here, this one over here is simply wrong, right? Because in our original declaration, we are saying it's a function with name and birthday, right? That's why you got to include all the information here. All right. Guys, any question about this? We can do one more, okay? Let's say we want to do another client supplier here. Let's say remind, which will, again, this can be one possible supplier we want to do, right? It could be. Let's say, not now. We want to focus more on this particular return type. Remind simply means, given a particular birthday, we want to get a list of people who were born on that particular date, okay? So now, how can we actually put this particular label here for remind? Can I just put, well, apparently you can see it's pointing to name, and the name is corresponding to the name over here, right? Can I simply say remind dot dot? No. So that will imply you only declare remind of type name only, right? But that's not, it's array of name. So what should I write? Array, and then, of course, it would be not so wrong if you say array of name. It's not so wrong, but it's kind of redundant, right? Because you're already pointing to name. So the correct syntax should be, rather than name, you say dot dot. Okay? So hopefully that clarifies your confusion. Oh, apparently that should be dot dot. Okay, I'll fix that on the slides. Should be dot dot. Any questions so far? We haven't got to the contract yet, but we will. Okay? Right, let's see the contract, which is more interesting. Let's do maybe one or two. So now let's see this. Let's say we are doing the put command. The put over here, we're adding a new record into the birthday book. Let's say we're adding, we don't have precondition, just for simplicity, okay? Let's say we're adding a new name, and then into the, with a particular birthday into the book. So now this is really important to get right. Okay? I'll help you think a little bit. I'll help you, okay? Let's say this, before we get to this part. and the rest can be done by you as well. Let's say we are trying to implement this using a hash table. Actually, let's say 2 arrays, just make it a little bit more different. Very inefficient, but that's okay. Let's say this is our implementation and this is our model. Okay? So now, let's say the implementation is such that we got names, we got birthdays. Okay? It's now pointing, let's say only got 3 records so far. Okay? Okay, and then let's say again, oops, Alan, Mark, and Tom, I don't know, January 5th, August 6th, and also January 5th. I just made it up, okay? So now this is the implementation, which might subject to change. That's private anyway. When you talk about the mathematical model, okay, over here, it's basically like that. You can draw like that. Okay, this part, this way we can draw. Okay, basically Alan over here is mapping to January 5th. Mark is mapped to August 6th. And then Tom is now mapped to this particular. Okay, they have the same birthday, which is fine, right? Good. Now, what's going to happen if we say, for example, let's make the simple case first. If we simply say put Jim, December 4. Oh, just a date. Okay, doesn't matter. Okay, let's see how things should be thought about. Okay, basically we are saying this. We are saying that somehow we're going to grow this array by Jim, and then grow this particular one by December 4th. What should be the corresponding operation on the model side, being a relation? What should that be? Anyone? We know what's going to happen in the implementation part, which is just some force of the array. But what should be the corresponding operation for the model being a relation? Yes. But, oh, you said append? Append is only a feature for a sequence. Think about relation as more like a set of pairs, right? What kind of set operation can you do?
Did you say it's a function?
Sorry?
Did you say it's a function?
It's a function, yes. Yeah. Actually, sorry, I was being a little bit imprecise. Yes, it's a function, yes. Remember, function is also a relation. Yeah, function, let me be precise. Yes, it's a function. Add something to a domain, add something to a range, I agree, but what's the corresponding operation for the relation, right? I give you 2 choices, okay? So there are actually 2 possible operations you can say. Either you say union, or you can say override. Unioned, so that's an immutable query, okay? Overridden. You got 2 choices. So now the thing is, you have to know what should be the difference. Yes, question.
Why do you use overridden and not override?
Oh, because we want to write that in terms of contracts. That you will see that, yeah. Again, okay, either it's an override or overridden, conceptually they're the same. But you want to know which context we want to use it. But now in this case, we want to use in the contract, so that's why it's overridden. Okay, so now I tell you the difference, okay? So now here's the thing. When I try to put something into the birthday, there is an implicit design decision we have to make. What if the name already exists in the book? What should we do? Either you can say there should be a precondition violation to say the name already exists. You cannot change their birthday. That's one design choice. Or we can say, if given that the birthday looks like this, I say put Alan into December 4th. I might still allow that to happen. In that case, I'm only changing the birthday for Alan from January 5th to December 4th, right? Either 1 or 2, right? There's nothing right or wrong. It's more about design decision over here, okay? Let's say we have the following design decision, okay? So the design decision is, if the name exists, Okay, it will simply overwrite the birthday. This is actually why you didn't see there was a precondition over here for the put, but it's a design decision. Okay, as long as you can justify why for your particular application it should be such that, then you'll be fine. Okay, let's say that's the case. So now, what should we do over here? Should we choose union or overridden? Overridden, right? If you only say union, you're just going to add Allen. You're still going to keep Allen and January 5th. At the same time, you're also going to get Allen and also December 4th. That's going to violate the functional property. So that's not good. Okay, good. So now, you can basically what you're saying is, if I say, for example, over here, let me just change this to Allen. If I say this is Allen over here, so what I will do is, first of all, I'm going to remove this particular link, right? Conceptually, just remove the domain value. And then Allen mapped to December 4th is going to be added. Okay, that's why it's overridden. So conceptually, when you are doing this particular put command, you're really doing overriding at the more abstract level for functional overriding. Okay, guys, is okay? Okay, you think about it. Sorry. The same name, yeah, that's exactly what I'm saying. So that's exactly this point here. So if you got existing name already, you simply override their birthday. So that's why we're using overridden as opposed to union. Yes. You can definitely try other combination of the operators as long as they work. But I'm just saying the easiest way to do this one here is overridden. Yeah. Yes. Very good question. What if the name doesn't exist? Let me explain that part as well. First of all, do we agree that in the case where the name already exists, overridden is going to work, right? Okay. What if the name doesn't exist? Let me put back over here. Let's say if I say put, let's say Jim, and then let's say November 7th. Okay, if I want to do that. First of all, Jim doesn't exist in the domain. Remember what we did previously in the exercise? The first stage, remove all the pairs that's related to Jim. Nothing to remove, so we don't do anything. And then add in this particular pair. So overriding will still work. Okay? So what that will do is nothing to remove for Jim, and then we add Jim map to November 7th. Okay? Good. So now, if you go back to this particular guy here, it tells you use overridden. And one thing to note, you asked me about whether I should use override by, overridden by. Overridden by is, again, an immutable query that you want to use for contracts. Okay? When you look at the API for the math models, whenever they return another relation, that means it's immutable. Okay? So we're saying that the model currently is equal to, you tell that the old version of the model deep twin overridden by that particular name and date pair. Okay? We use tuple for the pair. Any question about this? Of course, you need some practice, right? And think about it a little bit more. It might be a little bit new to you. That's okay. We okay? Okay. Let's do one more exercise over here. For this one here, I'll just tell you how they look like, and we can focus on that particularly, okay? And these are the rest of the contracts I'll leave to you. One specific one I want to explain, okay? I want you to look at, this one is pretty easy. You say nothing else changed. Since we're doing a query for the remind, so nothing should change, right? Just the deep twin version should be equal. I want you to look at this particular guy. Okay, I'll make it bigger for you. Can you just read it first? The pink one. We are apparently doing something called range restricted by. First of all, it's a query. Okay? We're saying that result, which is going to be an array of names, the size of the return array should be equal to somehow the model getting range restricted by D and then get its size. Can you make sense out of it? Okay, let's see. let's say this is the birthday book we have over here, okay? Let me get it clearer for you. Okay, the last discussion we're going to have, okay? Implementation and also model over here. Again, let's say we still go back to Alan, Mark, and Tom, okay? The array, that's the names, and that's the birthdays. Let's say Alan and Tom happen to be born on the same day. Let's say November 7th and October 10th, okay? So now, the model should look like this. Okay, that's the guy over here. Alan maps to November 7th, and Tom also maps to November 7th, and Mark actually maps to October 10th. Okay, that's what the setup. Let's say this. We are making the following query. We declare A to be an array of string. And then the book we are having over here, okay, that's the book we have. Dot remind. And then we say November 7th. What should be the return value of the array? Well, Alan and Tom, right? So these are the two persons we want to remind. So the return value over here should be just an array. Alan and Tom. What about the corresponding relation? What kind of operation should we do so that we can get a very similar relation, but somehow it only shows Alan and Mark? Alan and Tom, sorry, Alan and Tom. Should we do domain restriction, domain subtraction, range restriction, range subtraction? Something to do with the range, right? Because that's birthday. Should we do range restriction or subtraction? Restriction. Very good. Thank you. So that's why you will simply say model dot range restricted by, and then I will say November 7th. So what this will give to me is just another relation. Okay? It's going to give me this particular relation over here where I got only Alan and Tom. And then they simply map to the same November 7th. Okay? You can think about that, right? Yes?
Why don't we just assign the result to the model from?
Well, good question. Why don't we simply use model in the implementation? Because it's very inefficient. Remember we discussed before, we're going to use some deep twin in the model, and it's not really good. You really want to save make your implementation as efficient as possible. Yeah. Questions? All right. So what should you do with the math model? Okay. That's the last example I want to talk about. When you study for the math models, I would suggest the stack is very easy. I would say birthday book might be more worth more of your time. Okay. So when you actually look at, so what we got one design over here. I'll mention a little bit about implementation to make a point. So this is a complete design over here. Look at the every contract over here. I already explained two of them. Look at the rest to make sure that makes sense to you, or come to me for clarification. Okay. And now one more thing to say. When you look at the implementation part, the point to make over there is, now let's say this. If I decide to actually have some implementation. So that means if I decide to have implementation over here being, for example, a hash table, rather than two arrays. And for hash table, it's going to be the value first. It's going to be birthday and then also the name. Let's say that's my implementation, which should be exported to none. So now, should I change any of the contracts? I shouldn't, right? Because that's the point about using math model. So single choice principle. So now if I somehow decide my implementation should be a single hash table as opposed to two array, where should I change? Just the model, okay? So now your exercise, okay, of course, you can feel free to actually try to implement this. This is your exercise, okay? Try to implement the hash table for the birthday book. And then this part over here, is the only place you're going to mention about what's the relationship between the mathematical function model and also the hash table. That's the only place, nowhere else. Yes. The lab has two. Good question. I would say if we haven't decided yet, but maybe focus more on the exercise we gave to you yesterday about iterator and also generics. If you did decide to include math models, we'll make sure we give you some practice test so you can practice, no problem. Yeah. I'll let you know as early as we can. Yes. Oh, that's a good question. So I would say for those of you who really want to practice a little bit more about math models, you can definitely make, for example, a book, right? That could be either a relation or a function. Make a decision, try to make some contracts on that. Absolutely. Yeah, absolutely. All right. Any more questions about math models before we go to the design patterns? You okay? All right. I believe I cover all the slides, okay? Okay, so you want to familiarize yourself about other classes. Again, you don't memorize the features. Just try a few of them. In the exam or in the lab test, if we ever ask you to do contracts, we'll give you the API. Okay, don't memorize the features. Okay, and just other resources you can look into. Okay. All right. Let's now talk about the next design patterns. We got two more design patterns to cover for this course. One is called state pattern. The other one is called observer pattern. Okay, these two more. Okay, let's talk about this one here. Again, every time to introduce the design pattern, we want to know what kind of problem we are trying to solve. And this one is actually quite interesting. Okay, let's see. Let's say this is, let's say we are talking about some online booking system. I hope this link is still valid. Let me try. Good. Let's say this is kind of the application you would like to build, like the system. Oops, no thanks. Okay. Let's say you're building this kind of online flight booking system, right? Basically, what's the characteristic of such a system? You can enter some input on this particular page, and then after that, you can actually click on something to say, for example, next. I want to go to the next page. Or maybe if you enter something that's wrong, it might bring you to another page to say, well, you got to fix your information, right? So this is kind of the interactive system we want to build, right? We want to know what kind of pattern would be the best for this particular page. I can tell you visitor may not be the way to go on the first site, okay? Again, there's no silver bullet. Not necessarily every pattern should be applicable to every problem. So this kind of interactive system, like Amazon or eBay, many other interactive systems, there's a particular pattern for it, okay? But before we get to the pattern, we would like to see what are the possible alternatives, which may or may not be good. Okay, we want to see. Okay, I'm going to simplify the interface over here a little bit. Okay, just for illustration. Okay, what we will do is let's now consider. Let me just switch the slides to here. Let's say this kind of interface we have much easier to see. Okay, let's say we still talk about flight booking for the system. Let's say you got to enter maybe the source city, destination city, the departure date, the return dates, and most importantly, have a look at over here. After you have entered information, you are able to say either I can key in 0 to say, now I want to exit. I don't want to continue anymore. I can say 1, show me the help page. I can say number 2, I want to do a little bit further inquiry. Okay. Number 3, I want to reserve a seat for this particular dates. Okay. And of course, let's say if I go for number 3, I go to another page. From that particular page, at the end of the page, I might have, again, a number of choices for me, right? To say, oh, you can either go back, or you can exit, you can get help, or you can now go to payments page, right? That kind of makes sense. Okay, that's kind of what we have. What kind of sketch would you do to design such a system? Oh, flowchart, that's interesting. Oh, did you guys do flowchart back in 1012, by the way? I'm just curious. Oh, if no, that's okay. Have you heard about DFA before? DFA, NFA? Do you still remember what it stands for? No, it's okay, yeah. Non-deterministic finite automata, that's okay, yeah. Anyway, finite state machine or finite automata might be the way to go, like a flowchart basically. You want to show from the particular states, what are my options to go out and maybe sometime come in back, right? It's like a graph. Okay, so now our first agreement would be somehow we have to use a state transition diagram somehow when we sketch the design. Okay, let's have a look. Okay, so now, okay, we talk about finite state machine. People usually say FSM, okay? You have a state transition diagram, which we're going to use for this particular lecture. Okay, let's have a quick look, just to get yourself familiar. So when you sketch your idea, you can say, so that means it's the initial states, and then initial states, which is like option 1, right, state number 1. And let's say in the initial state, we can choose to go to 3, which will go to flight inquiry. From there, we can choose number 3 and then go to seat inquiry. And then we go to reservation, we can go to confirmation, and then we are done. And then we go back to initial state, and back and forth, right? That's kind of the state transition diagram we have. But that one there is a little bit too abstract. How can we move gradually towards the implementation? Well, you learned in 2001 something called state transition diagram, right? Maybe? I hope. Okay, if you haven't, let's see it. All right. State transition diagram is very easy to draw. It's more like a two-dimensional table, okay? And then you simply list every row corresponds to a particular states, okay? State number 1, 2, 3, 4, 5, 6, right? Because we got 6 different states. 1, 2, 3, all the 6 states. And then over here, we have each column correspond to, if you make a particular choice, so we got 3 possible choices basically. Okay, I'll give you one example. Okay, let's say this. If I'm currently in this particular states, okay, how many options do I have? 2, apparently, right? I can either go to state number 1 using choice number 2. I can go to state number 3 using choice 3. And notice that the diagram you draw is not a DFA. Do you see why? I'm just curious about your knowledge about 2001. Huh? It's more than one choice, and did you notice that there is no choice number 1 from state number 2? Okay, anyway, just to confirm, okay? But you're right, that's exactly right. All right, very good. So now, if I want to specify this particular move, I'm now in state number 2, I make a choice, number 3, and then I'll go to state number 3. How does that reflect on the table? I'm now currently in state number 2, and then I'm trying to take the choice, number 3, so this will be my result, which will go to state number 3. Okay, that's how you see it. So now we are very close to some kind of implementation. Very close. What will be the data structure to use? Can a single array do it? Actually, in some way, yes. Because back in year 2031, I'm not sure if your instructor mentioned, 2D array is just like a single array with a different addressing mechanism, but let's not worry. It can be doubly linked list, but how do you distinguish between rows then? Huh? But oh yeah. So when you say a doubly linked list, right? But if you only got a linear structure over there, how can you represent this table here? If you only got a doubly linked list, how do you know which part of the list should be for row number 1 and which part of the list should be row number 2? Okay, so that's not going to work. So 2D array, yes, 2-dimensional array. Okay, or you can use an array of array. That also works. All right, that's about the little bit design. And what I will do is I'm going to present to you 2 possible designs. Hopefully, we can finish at least the first one, a little bit of number 2. And then we can talk about the actual solution next time. Okay? The first design goes like this. Let's go over a little bit slides. And tell me how you think of it. Oh, by the way, so now a little bit more facts about this. For the design, when you sketch, you have to know that this kind of system has its own complexity. If you have a large number of states, back in 2011, let's say you got n states, how complex can the graph be? N squared? transitions, right? Because maybe every state has a transition to every other state. In that case, it's n squared. Okay, so that's kind of complexity you want to deal with. So if you have a very large number of states over here, that's a design challenge. You have a large number n of states, and then big of n squared. Okay, that's a reminder of facts. So now, and also, let me just show you that. Every time you want to think about design, think about extension or maintenance. What if I want to extend my state space, or I want to shrink down the state space? For example, let's say this. Easy thing to say. Let's say somehow for efficiency, I don't want to have these two separate states somehow. I don't want to. I want to collapse them into a single state, let's say. So in that case, I'm going to make this a single state. So 2 and 3 should disappear. And then 3 will go to this particular state. And also 2 will go to this particular state. And then this state here, if you follow 2, you're going to go back to 1. If you go 3, it's going to go to this one here, right? Just a new state, basically. How do you solve that in your particular design? It's a very important issue. I want to mention that, yeah, okay? But we're going to see, okay? So extension or modification is really important. So that's something you want to pay attention to. Okay, we want to have a very general solution for that. But before we get to the state pattern, I want to show you 2 possibilities. And let's criticize on that. The first attempt can be done in a language like C, right? Or even the MISP language that you learned back in 2021, assembly. You can do it, actually. Let's see, if you wish. Okay, let's see. Let's see how we can do it. Remember, we got 6 different states, right? Let's say because we got 6 different states, we got 6 different labels. Okay, we got one label for state number 1, initial panel, and label number 2, flight inquiry. Label number 3, seat inquiry, and then reservation panel, and then confirmation panel, and then final panel. The good thing is everything might just stay in a single place, somehow, just a single file. That's what I meant. Okay, we got labels, and then let's give you one example. Let's say for state number 3, how should we program that? Okay, so now let's say for this particular label, maybe in other place of your system, you'll say the following. We're going to say have a loop. We say we're going to display some information on the panel to say, okay, welcome to whatever company, and now tell me your departure date and return dates, something like that. Right? Display some information, and then we are only going to end the interaction for this particular state if the user has not entered the wrong answer. For example, if they decide to enter some departure date, it cannot be November 31st, right? Cannot be, right? You got to do some validation on the input. And also, wrong choice is also important. Let's say for state number 3. For state number 3, if you're over here, apparently you only got the choice of 3, or you got the choice of 2. If you say 1, that's invalid. In that case, you should not allow the user to proceed, right? So there's some validation that has to be done. Okay, that's basically what I meant. Read the user's answer, and then you want to know what the choice is, and to go further. Questions?
For the until part,
yeah.
When we use not instead of just like wrong answer, if you use while loop, you would run while it's not the wrong answer.
Oh yeah, because while loop in Java, well, the reason I'm using until is because somehow up to now you kind of program in iPhone. I just want to show you that. Because while the user has entered something that's wrong, then I will keep interacting with them until they have entered the correct information. Yeah. What we will see in the last 2 classes of this course will be, we'll try to prove the correctness of loops. In that case, we'll stick with this particular syntax. But yeah, anyway. All right, and then after reading their choice for the next step, we want to say, okay, basically, if they have entered the wrong answer or wrong choice, then we're going to give them some error message, right? And then we're going to process their answer. And then we're going to say, in the case where the choice, which is C, if it is 2, then we go to, give me one moment. If they say 2, then we're going to go back to label number 2, okay? If that's 3, we go to label number 3, back to the same states. And then, etc. Okay, that's kind of the pattern for state number 3. Questions? Yeah. Give me. I would explain it to you. Okay, if you think about this, this condition here tells you that you're going to exit from the loop as soon as this is true. Agree? Okay? So now let me say this. Whenever you have this from until, let's say some Boolean condition here, right? So this B simply tells you as soon as B becomes true, then exit from the loop. Whereas what you're used to, maybe back in Java or C, right? Let me just mention that anyway. So when you say while, let's say B, you're saying that as long as B is true, do you exit or stay? Stay, right? Very good. Okay, stay. You can see somehow the B here and the B here meant a completely opposite thing, right? Okay, good. So now let's go back to this guy here, over here, okay? If you think about it, learn about De Morgan, remember? De Morgan? So that means we're going to exit as soon as not wrong answer and not wrong choice. That's basically what we are saying. As soon as the user has not entered the wrong answer and they have not entered the wrong choice, we're going to exit from the loop and then proceed to the next stage. That's what we are saying. To reinforce your understanding, think about how you might rewrite it using while. Okay? The formula is very easy. You simply take the negation of this guy here. You're basically saying while wrong answer. Right? I'm simply get rid of the not. Okay? Wrong answer or wrong choice. And then I'm going to do something. So in the while version, they have the same meaning basically. But in this case, you're saying either the answer they have entered is wrong or the choice they have entered is wrong. I'm going to stay in the loop and keep interacting with them. I will only exit if they have done both correctly. Okay? Questions? If you think about this loop, it's more like to say, I'm going to keep interacting with the user and prevent them from proceeding to the next stage, as long as they actually have entered the wrong information to me. As soon as they have done things correctly, they have entered the correct credit card number, they have entered the wrong, correct departure return dates, and then I'm going to let them go proceed. Okay. Any other questions? Okay. It's actually worth clarifying this, otherwise you may get confused later. Yes? Until simply means as soon as it becomes true, I'm going to stop doing it. Basically, I'm saying I'm going to keep interacting with the user until they have not entered anything that's wrong, or they have not entered anything that's wrong choice or wrong answer. Yeah. Okay. Okay. That's okay. Yeah. Interesting. Okay. All right. Let's talk about criticism. Any criticism about would you rather go for this design yourself? It's basically you can do it in MISP, I believe. Aha, single choice principle, very good. So why would single choice principle be violated in this case? Okay, in many different ways actually. Okay, the easiest way to see is to think about, I only show you the information for this particular states, like over here. Okay, now would the definition for two be very similar or very different? Very similar, right? I basically will follow the same pattern. The only difference is I might say the choices I'll put here may be a little bit different. Okay? And also maybe the way I validate the user's wrong choice or wrong answer might be a little bit different. But the general structure is being repeated for as many times as it is required for the number of states. Because I got 1, 2, 3, 4, 5, 6 different states, I got to repeat this 6 different times. So that's one criticism for sure. There's another thing I want to mention. Yeah, I'll take a question.
I understand wrong choice is like the number that tells you what state to go to. What's wrong answer in this context?
Oh, actually, wrong choice, okay, different. I'll give you an example. Wrong answer could be, for example, let's say we are trying to reserve a seat, for example, right? Wrong answer, wrong answer could be, I tell you I'm going to depart on November 31st. Cannot be true, right? And wrong choice could be, let's say I'm currently in state number 3. You can see in state number 3, according to our design sketch, you can either go for 3 or for 2. But somehow the user said, I want to go to state number 1. That's wrong choice. Yeah, that's just terminology here. Yeah. It's just some kind of validation you want to do. That's the point. Single choice principle, good. What about the runtime? Would it be easy somehow for you to trace the program? Basically, if you want to trace this in the runtime, basically what you will see is something called spaghetti code. Okay, I'll show you that. Name, and then I'll illustrate to you. Bob spaghetti. Okay, spaghetti code simply means at the runtime, if you try to do that, what you will see is if I start with this particular states, and then what you will see, I'll keep jumping between maybe from 1 to 3, 3 to 6, 6 back to 5, 5 to 6, back to 4, and then go to 6, and go to 3, go to 1, etc. It's like a spaghetti, isn't it? Well, that's why people call that. Okay. The point is, when you try to trace this particular program at the runtime, you'll keep jumping back and forth between the labels. It's very hard to debug. It would be much nicer if somehow there's a single it's more like a single linear or two-dimensional array for us to see where exactly how the transition should be made, rather than jumping back and forth. That's the point. Okay. Anyway, the first design is pretty poor. Okay, I'll just mention that anyway. Okay. Hopefully, you wouldn't choose that for your projects. Hopefully, right? You may. That's fine. All right, that's the first design. Okay. We got. Let me just do very quickly the second one. I'll give you a little bit of feel about second one. We can talk in more details. Okay. What we really want to do is we want to improve the first design a little bit. We're going to go to some second design. Second design, as we will see, will be much better, but still not perfect compared with some true OO design. Okay. I'll mention a little bit just to give you an idea. We basically want to say we want to have a single transition function in the system rather than using labels, to go back and forth. Okay. And now, if we do a transition here, and you can definitely apply some contracts. Let's say we have, so for the transition function, we're going to say what's the source and what's the choice, and return the corresponding output states, right? I'll show you some example over here. Okay. What you will see is something like this. This is our transition function over here. Okay, transition function. Okay, it's going to take the source states and the choice, and then it's going to return the destination. But how do you implement that? That's a issue. Okay, remember this is a state transition table we have, right? How do we? Of course, at the runtime, it can just be a two-dimensional table, right? So now, can you explain what this really means and what should be the output? If I say transition 3 and 2, what should that be? 2? Good. Okay. Let's make sure you understand that. Okay. Now we're going to use that later in both the second and third design. Okay. Basically, whenever you say transition here, starting from this particular source, I want to make this particular choice or transition. In that case, this basically corresponds to I'm in state number 3. I want to make choice number 2, and then the return value should be just 2. Okay, that's how you see it. Okay, it's just one way to actually implement it. Okay. Any other questions? We okay? Yes.
Let's say we have in our code we have transition 3.2 and then we have transition 3.3 right after. After the first line, we're in state 2. So then how can we go from state 3 to?
Oh, so they're independent examples. Okay. Yeah. So I just want to show you 2 different examples. Okay. So these 2 are completely independent. How about transition 3.3? 3 and then 3 would be returning 4. Okay, just for information. Yeah, they are not related.
So we have to do checks like when we're doing transition, we have to check to make sure we're actually in the state that we're trying to transition from?
Yeah, you may do some additional contract as well. Yeah, you may. All right, let's now do a very quick go over. Okay, I want to show you a quick diagram just about the design. Okay, so this is the second design. And this design will definitely, I'll talk in details more from Tuesday next week. This design over here can be done in a language like what you learned in 2031, like a C language, where they don't support OO. If you try to implement this particular design in an OO language, like a Java or IFO, it will work, but that simply means you don't quite understand OO properly. Okay? If the only language you have to use is C, which doesn't support OO, this will be suitable design. But in your case, you do have OO. But we have to criticize on this. Okay? What you will see is basically you will have some, this is more like a main method, like a main function in your Java or C course. And then the main function over there has step number 1, step number 2, step number 3, and step number 4. So 4 different stages for the main function. And for this particular stage, you have some sub-function, basically. Okay? When I say execute state, I'm saying depending on where I am in my state diagram, I'm going to say, let's say this. So I have some current states, and then that's simply some integer. And then when I say execute state, depending on what the value is for CS, I'm going to do display, followed by read, followed by validation, followed by error message, followed by some process. That's exactly what you saw in the panel over there. Okay? So for this particular third stage, you got sub-stages. Okay? There's no OO. No. Okay? I'll give more examples next week when I talk about it. Okay? Any question just conceptually? Okay? So next week, Tuesday, I should tell you a little bit more about what I'm going to do. I'll talk about this design here and see some insight of moving into OO. Okay? If you bear with me, I just need 2 more minutes from you, please. That's why I want to finish earlier today. Give me 2 more